This question asks, which reactions below will form a di-substituted alkene as the major product? So this question is fairly complex because there's a lot going on. We have 3 different reactions to consider, and we have a couple of definitions, such as a di-substituted alkene, that we also have to think about and know what that means. All right, so first things first, I'm going to recommend that we look at each reaction and think about what mechanism is happening, and also think about what product is being formed. So in reaction number 1, our alpha carbon is a tertiary alpha carbon, and our reagent is a strong base only. We know that it's a strong base because the oxygen will have a minus charge and the sodium will have a plus charge. And we know that it's a base only because it's a pretty bulky base. Okay, so we can even add that in, strong, bulky base only. All right, so with a strong base only and a tertiary substrate, that's going to favor the E2 mechanism. With E2, there's a lot of different exceptions to remember. In E2, if you have a bulky base, you'll typically observe that you're going to remove one of the more accessible hydrogens versus a hydrogen that has more steric hindrance. So we often find that we make the Hoffman product instead of the Zaitsev product with a bulky base. If we think about what hydrogens are available to us on our substrate, we have hydrogens out on a primary carbon versus hydrogens at a secondary carbon. And so the primary carbon and its hydrogens will be more accessible to the big bulky base. So those are the hydrogens that we're going to be pulling off. So the product that we make is going to look like this. That's the major product. We'll also see some minor product from the secondary carbon and its hydrogens, but the major product will be the Hoffman product, which is, in this instance, going to be favored. In reaction number 2, we have another tertiary substrate, and we have a strong base / nucleophile. We know that it's strong, again, not strong, we know that it's a strong base and nucleophile because of the negative charge on the oxygen atom. It's also pretty small, so we can include that too. That's important, again, for thinking about, do we form Zaitsev product, do we form Hoffman product? Whenever you have a strong base and a nucleophile and a tertiary substrate that's got a lot of steric hindrance, that's also going to favor an E2 mechanism. So if we think about the hydrogens available to us, we have these options. A small base will be able to fit in to reach these secondary, or these hydrogens on a secondary carbon. So we'll be able to form the Zaitsev product in this instance. And our Zaitsev product will look like this. Reaction number 3, we have a primary substrate and the same small, strong nucleophile / base that we saw in reaction 2. In this instance, because we have a primary alpha carbon and no steric hindrance on the beta position, we are going to favor SN2 instead. So the SN2 will be major, and so that will give us a product that looks like this, an ether. All right, so we thought about each mechanism that's involved. We thought about the major products in each case. Okay, this will be the major product here for reaction 2, and then the red ether is the major product in reaction 3. Each of these reactions will have minor products, but the question's only asking us to worry about the major products. Okay, the last part of the question is that we're looking for a di-substituted alkene. So that means the alkene has 2 R groups coming off of it. So if we look at our products, we have a di-substituted alkene in reaction 1. We have a tri-substituted alkene in reaction 2. And in reaction 3, we have a substitution product. So not a di-substituted alkene. So if we're going to answer the question, the answer is going to be B, 1 only, because that's the only one that makes a di-substituted alkene as the major product.